Okay, hi again. This is the second part for your lecture on Tuesday. And what I decided to do was to start covering the replacement analysis topic. And we're going to only discuss the introductory part of this lecture. So this is also, you're going to have some problems from this first part of the lecture on your homework. So some of the topics that are included in this lecture include the replacement problem. So we're going to explain what is the replacement problem. And we also going to explain how to solve this problem. And we're going to use a diagram which basically helps you to guide you through the process of deciding what type of analysis you're going to use depending on the problem you have in hand. We also going to talk about how to compute the minimum cost life of a new asset, which we call the challenger. We also are going to discuss what is the defender's marginal cost data. And we're going to discuss the three types or three techniques we have for replacement analysis. So this is basically what we're going to use to solve our problems in the replacement analysis. The last two things basically are complications in the replacement analysis. So we're going to discuss what are some of the complications you can find in these type of problems. And the last thing is we also going to include taxes in our analysis, so that's the last thing we're going to do. So as an introduction, the question we want to answer in this lecture is, should the existing equipment be retained or replaced? So if you are running a manufacturing process, you have a machine that is part of that process, and this machine has been used for a couple of years now. You want to know if that machine is still profitable in terms of if it is producing as you expect, and if there's no other better option outside that you can replace that machine and be more profitable. Okay, so we're going to call the defender our existing equipment. So that machine that you have in your process running right now, that's your defender. And the challenger is the best available replacement equipment. So you're going to look for a replacement. You have to be sure that you find all the options that are available right now or at the moment of your analysis. And you're going to compare those new machines with the one that you have currently running your equipment. So if the defender proves to be more economical, so defender prove more economical, it will be retained. On the other side, if the challenger prove to be more economical, it will be installed. So you're going to replace the defender with the challenger. Economically evaluating the existing defender and its challengers is the domain of the replacement analysis. So that's the focus of this lecture. Okay. So let's talk about the replacement problem, because right now you will say, okay, but that's what we have done so far. But no, there's one difference with this problem. So before we get to that point, we need to state several things. So assets of all types eventually lose its value and needs a replacement. So this can happen because of several things. So for instance, obsolescence. An example for that is our computers. So if you have an old computer, at some point you'll feel the need of replacing that computer because you know that your computer power can be improved. The other thing to consider is depletion and also deterioration. And that is the case for most mechanical equipment. So for this type of equipment, we are almost guaranteed to have different useful lives. So we will make the Defender Challenger comparison on the basis of the equivalent uniform annual cost or cash flow. So as you remember, for this technique, you don't need to have the same time horizon or the same time period for comparing alternatives. You can use a different one, and that's the advantages of this method. One of the advantages of this method. So the question is not if the Defender will be replaced, but when it will be replaced. So you know at some point you will have to replace your equipment. And so far that has been a given in our problems, but in reality that is unknown. So the only case that you, and that is uncertain as well, is if the equipment fails, and there's no way of fixing it, you know that you need to replace it, but you don't know when that's going to happen. So what we're going to do in this lecture is we're going to analyze our options, and we're going to decide up to what point or up to what time in the horizon this equipment that I have in place running my manufacturing process is still profitable, or if after 5 years I will need to replace it, for instance. Okay? So let's show you that replacement analysis decision map. And initially this will look, it will not make a lot of sense to you probably, but you will see that this is going to become very useful as we progress in the lecture. So this is our replacement analysis decision map. So the first thing you need to do is to identify the alternatives you have for replace this asset that you have in place. So one of the alternatives, of course, is the Defender. So that's the current machine. And also you will have to find what is the best Challenger. So the first question you need to ask yourself is, do you have the Defender marginal cost data? If you do, then you have to ask yourself another question. Is this marginal cost increasing? Now, if you don't have the Defender marginal cost data, then you have to find the equivalent uniform annual cost or cash flow over the given life of the equipment. But going back to the second question, do you have the Defender marginal cost, if that cost is increasing? If your answer is yes, then you're going to use the analysis technique 1, which compares the Defender's next year marginal cost with the Challenger's equivalent uniform annual cost. If you don't have that information, or excuse me, if the Defender marginal cost is not increasing, then you have to find the lowest equivalent uniform annual cash flow for the Defender. And that basically you find that and you use the analysis technique number 2, which compares the Defender's lowest equivalent uniform annual cash flow with the Challenger's equivalent uniform annual cash flow at its minimum cost life. Now, if you don't have the Defender marginal cost data, then you will have to find the equivalent uniform annual cost over a given life, and then use the analysis technique number 3, in which the Defender's equivalent uniform annual cost over its remaining life is compared with the challenger's equivalent uniform annual cost at its minimum cost life. Okay, so again, this is a decision map that is going to help you a lot to solve these type of problems. We haven't explained the analysis techniques yet, but you're going to be referring back to this in the next couple of minutes. Okay, so choosing a single challenger. So again, you have to compare your defender with some challengers. So we need to, from the group that we have of challengers, we need to find a single challenger. So when considering replacement, we have many challengers, but our analysis techniques require us to choose just one. So how do we do that? But you know how to do that already. You can use the net present worth, the equivalent annual, uniform annual cash flow method, the internal rate of return, or the benefit cost analysis. Just these are only few examples that you can use. But the important point is that each challenger must be evaluated at its minimum cost life. Minimum cost life. And we're going to explain what that is in a second. So the minimum cost life of a new asset, and we call that the challenger. So what is the minimum cost life? So far we have been treating an alternative as having a fixed useful life, but viewed in the context of replacement analysis, an asset can have several possible lives depending on when the asset is replaced. So the life which minimizes the asset's equivalent uniform annual cost is defined as the asset minimum cost life. Okay, and let me illustrate that with an example. So in the next example, we have a piece of machinery that costs $7,500 and has no salvage value. After it is installed, the second year maintenance cost is $900, and this item will increase on a 900 arithmetic gradient in subsequent years. The first year operating expenses for the machinery will be $500 and will increase on a $400 arithmetic gradient in the following years. If interest is 8%, compute the machinery's economic life that minimizes the equivalent uniform annual cost, which essentially is the minimum cost life for this asset. Okay? So in order to solve this problem, you have to list the time period for this particular machine. So in this case, we are listing 15 years. So that's our first column. And then you have to evaluate each cash flow as in an annual base for the specific duration listed here. So for instance, we're going to start with the equivalent uniform annual cost of capital recovery cost. So that means that's for your initial investment of $7,500. And we're going to change that from the present to the annual base. So we have a given P factor with an 8%, and this N is going to be changing depending on the year in which you are at that point. So if you find the annuity for 1 year, a given P factor for 8%, that will give you $8,100. If you find the same for n equals 2, then that would be for $4,206, and so on. So that's just for the initial investment. You also have to consider the maintenance and repair cost, which is our third column. So we're gonna use the information for that. We use a given G factor, so we have a gradient, an 8%, and also this is going to be changing depending on the year in which you are at that point. So for the first year, that amount will be 0. For the second year, using this factor again, changing n, that will be equal to $433, and so on. So the last cash flow we have is the operating cost, and for that we can derive this expression. And again, we're going to apply the same thing we applied for the first two cash flows. So we're going to use this expression, and we're going to change n depending on the first column. So for the first year, you know that the gradient will be 0, so the amount you will find is $500. But for n equals 2, that expression will have a value. So that will make the equivalent uniform annual cost of operating costs equals $692. So again, we have 3 cash flows, which are here. 1, 2, 3. We need to evaluate each cash flow using an annuity base. So we have them separate, and we are computing the value of each cash flow for each time period that can occur from 1 to 50. And as you can see, those numbers change according to the number of years that you're considering in your analysis. So having this information, now you can compute the equivalent uniform annual cost total, which is your last column, and you can see how those totals change throughout the years. So for 7 years, which is this case, we have that our equivalent uniform annual cost for 7 years will be $5,442. But that will be different for 8 years. That amount will be a little bit higher. And you see how those totals change according to the number of years you use for your analysis. Okay, so now in order to find the minimum cost live, you need to identify from this column, the last column, which one provides you with the minimum. So if you find the minimum from this column for the equivalent uniform annual cost, the total, that will provide you with the minimum cost life. So if you search, this one decreases, 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 then you'll see that this increases, decrease, 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 and that when you get to year 5, you'll see that those amounts start to increase. So there's a point in which you reach your minimum, and that point is right here. No, sorry. It's the amount for that. So your minimum is right here, and that occurs when n equals 4. Okay? So your minimum cost life for this particular problem occurs when n equals 4 years. Okay? So for illustration purposes, here I'm showing you how the cost for each cash flow change when you compare across time. So you can see how the equivalent annual cost for the capital recovery starts to decrease from the beginning up to the end, but there's some costs that are increasing throughout the years. So for instance, the equivalent unit for annual cost for maintenance and repair. So when you put all these costs together and you graph the total, this is how that cost behave. And you know for sure that the minimum is somewhere here. So this 4 is providing you with the minimum cost line. Okay? So I'm going to stop my lecture here for this topic. I'll review this in class before continuing this lecture. But as I mentioned at the beginning, there will be 1 or 2 questions referring to this material that we cover in your homework. Okay? So that's all I have for this video recording, and I'll see you next week.